Welcome. In this video, we will explore the most severe type of power system fault, that is the symmetrical fault. We will see how it occurs, the two main types, key features, causes, effects, and the protection methods used in the practices. So before going into the deep discussion about the symmetrical fault, first, we'll see what is symmetrical fault. The first sentence he has written here, the fault which involves all the three phases is known as the symmetrical fault. Suppose we have the three phases R, Y and B. So when it involves all the three phases, then only it is called the symmetrical fault. Such type of fault remain balanced even after the fault. Suppose before pre-fault and the post-fault conditions. Suppose in the pre-fault conditions, before getting the fault occurs, suppose the current IA is flowing through this one, IB is flowing this one, and IC is flowing through this one. So after getting the fault, suppose the current IF is flowing and the IA will flow. So after getting the fault also, the same current will flow through the system. So the third point is written, the symmetrical fault mainly occur at the terminal of the generator. Suppose, let us suppose we have here the power is getting generated from here, it is getting transmitted. Here the power is getting transmitted, and this is the utilization side. So this is called the transmission side, and this is the transmission side. This is at the generation side, and this is at the utilization side. So mainly the fault occurs at the generation side. At the generation side, the resistance is higher. Resistance will be the higher. Resistance will be the lower. So current will flow higher in nature. So resistance is the lower, so current will flow the higher. That's why this type of fault is very severe in nature compared to the other types of fault. Why resistance is lower? Because when the power has been transmitted from this side, so it has passed only to this side, not even transmitted. So at this point the resistance will be lower, and if resistance will be lower, the current will be higher. So whenever the fault will occur at this point, so it will be very severe in nature. Next point that we have, the fault on the system may arise on account of the resistance of the arc between the conductors or due to the lower footing resistance. The symmetrical fault is subcategorized into line to line and line to line ground faults. So it is categorized into two types. First one is the triple LG fault and triple LG to ground fault. First and the second, we'll see the two in very deep discussion. So now we'll see here that line to line fault. So word itself only shows that, suppose word itself has line to line. Suppose this is the R, Y and B conductors. So here it is said line to fault. So all the three of the conductors getting involved in such type of faults. So either the fault can happen, suppose but it is not grounded, but it is not grounded in this type of fault. Let us suppose the fault occurs and three of them had been attached to this point. Yes or no? if the tower has been fault here, and because of this one, so all of them getting fault and getting touched at this point. So such type of fault is called the line to line to line fault. So here I have written such type of fault are balanced, that is the system remains